Welcome to the Mad Doctor's Lab app file dissection. Hey, I'm Eric, and sorry about the stupid title. What I want to do today is look at app files. We create app files every time we build and deploy, and it's become a natural part of being a Business Central developer. But what is an app file? What's in it? How does it work? So I thought it would be fun to spend a bit of time in a video today on just pulling one apart and see what's inside it, how it's actually made, what's in it. And somebody would say, Eric, it's just a zip file of all the stuff that you have in your extension folder, so that's it. And that is certainly not wrong, but it's not true either. So there's more to the eye, more going on that you would. I don't know what the saying is, but you know how I get all confused with words sometimes. Anyway, let's take a look at it. And I have prepared some files. And I'm close to tilting something here. I shouldn't tilt. So here is my screen. And I have I've collected some app files. One of them I have is this guy, the app file from the tic-tac-toe game that we did on the channel a couple of months back. If you haven't seen that video, that's because you perhaps were not a subscriber at that time. But if you're still not a subscriber, please do subscribe, because that helps me a lot, and then you won't miss great videos like the one we're about to do now, and the tic-tac-toe video goes, what's that one? Anyway, so we can see here that we have a tic-tac-toe app file, and it's 28,271 bytes. And I have associated my 7-zip program with .app file. So whenever I want to run a .app file, it actually opens with the 7-zip, and this opens. This is a zip file. That's interesting, but not so quick. So let's say we copy this guy into app.zip, and let's try to open that one. And the dramatic error happened on another screen saying, this is not an archive. So, case proven, I guess. This is not a zip file. So what is it? Well, and why can 7-zip open it? Let's get rid of that one again, and then just open the other one, unless I still have it open. I do not. Let's open that one again. And go to File and Properties. Let's see what this actually is. So, well, this is a zip file. We can see that clearly. And we can see, what can we see? We can see that there is an offset of 40 bytes. That seems strange. But other than that, this looks pretty normal. So let's unzip it and see what's inside. Actually, I want to do one more thing. So what you can actually see here again, the file was 28,271, but this guy clearly said that the physical size of this guy's is 28,231. So what are those 40 bytes? Well, we'll find out in a bit. I promise you. So I have already unzipped this guy because it's clearly easier to use Visual Studio Code for everything. So I could actually have done unzip from in here if I installed something that emulated 7-zip, but I have not. So in the app file content folder here, I unzipped my tic-tac-toe thing, and we can see that, well, starting from the bottom, there's simple reference.json. So here is a JSON file, and these are all the symbols that, you know, there's name, blob, temporary. These are all the bitmaps in the table, and these are basically the symbols. So if I do the classic one here and open with the AZ, we can see that there are enum, position, types, and if I go to open symbols in new tab, I may be breaking this one, but we have the symbols, even though we can see that if I go back and look at the symbol reference, let's close this thing off because it gets too confusing. We can see that what we did in the enum video, where we used enums as text constants, those text constants are also now part of the properties, the symbols, which is pretty funny. So these are the symbols. That's great, and that's if we had just an app file that were just symbols, this is all we would get. But we have more. What else do we have? We have a file called navx manifest.xml. And in reality, this is just the app JSON file compiled into being XML, which is pretty hilarious, I think. Clearly, somebody at Microsoft were not speaking to each other, and one side, oh, we want JSON, oh, we want XML, and well, clearly one used JSON and another used XML, and the compiler team was the guy who had to convert their JSON to XML. I find that pretty funny, but the content here is just the app JSON file in XML. Then we have a file called navigation XML, and that one is actually pretty interesting. So you know, when on objects you define a usage category, and you need to also add an application area for that. That actually gets in here. So this is the you can see it even has the departments, like you know from the old nav menu. So this is for the departments menu. So to get tic-tac-toe into the search function and what captions and so on, and then it needs to run an object and run objects file for a page 54500 in the task. So that gets compiled into navigation XML. Medias, if we had a logo we should have a logo on the tic-tac-toe game, but we haven't. Documentation, comments. This is a hacker channel, we don't do comments, so I guess that's pretty empty. And then a weird file telling that these are some extension types. That I guess that's in the file. Not sure what the purpose of that one is, but it's there anyway. So the last two things that's in here are two folders, one called source and one called add-in. And you know, the common, it's just your extension as a zip file. So if we go and look at this, here is the tic-tac-toe game. You can see that we have a folder called data and a folder called game engine and images and JavaScript and UI. That's what we have here. So none of them are called source, but if we open up source, we can see we have data, game engine, JavaScript, and UI. So images are gone. And let's look at images. So images are some PNG files, and they're just ignored. So they're never compiled. They're never bought with the system. In these files, we can see we have all our AL files, and these are exactly the way they usually look. The space has been replaced with a an escape code in the name, but this is just the raw file with, let's see if we had, where did we do the common stuff? We did that up here where in the enum video where we changed the image array to use the enum text constants. And UI, the same thing. So the JavaScript folder is interesting because there's only one file in here, user control AL, and if we go look in the actual app, we can see that there are 2 JavaScript files in here also. So if I go back here, those JavaScript files are now moved to the add-in folder. And in the add-in folder, I see, well, ignore this one for a second. There are 3 entries. There's a source entry that has the 2 JavaScript files. Then there's a control add-ins.doc file, again, an XML file. I can't remember if we can format. No, we can't do that. Anyway, so this is like the old, how you did control add-ins in nav 2018, where you created a zip file and a docket kind of, I can't remember what the name is. This is so long ago. So there's also an XML, HTML.zip, so the zip file, I unzipped that one, and that one has, again, this is our control add-in AL file converted to XML with one of the scripts embedded, but it also has the other script. So the startup script has been embedded into the manifest, and the other script is sitting as a script. That's quite interesting. Anyway, so the control add-in gets moved around, but in reality it's still the same pieces, just moved around. So that's more or less the content of an XML, of an app file. But so that explains the 28,231 bytes. Remember, that was the number. But we had that strange offset to get to the 271. So let's look at those 40 bytes. And there's nothing like a good reason. There's not like a good reason. Okay. You're on a hacker channel, so let's bring out the hex editor. I think that was what I wanted to say. So here is a hex editor. So a file is made up of bytes. In this case, we have 28,271 bytes. You can combine multiple bytes to be something bigger. So an integer is 4 bytes, and a word is, depending, well, there's all sorts of names, and depending on what platform you are, stuff can be 8, can be 16, can be 32, can be 64, and so on. And the way binary data is stored, and this is like I did a video on this where we created binary WAV files with a stream. So you can find that video if you want to see how you can actually create files like this. Anyway, so what we can see here is that if you ever have looked in a classic zip file, and let's actually go out here on the, you see, let me go in and find that html.zip. Now I'll do type html.zip, and I get random noise. Well, not random, but I do get some noise. But what we can see is that the 2 first characters of any zip file out there starts with the letters P and K. For Phil Katz, the guy who invented the zip format back in 1993, after he lost a lawsuit from he created PK on Xarc, that the ARC format, and he did not have the source code to be allowed to do the ARC format, and then he invented zip instead. Long story. Anyway, so Phil Katz prefixed all the zip files with PK. But when we look at this app file, we can see that PK is clearly not the first two characters. But we can also see that if we get down to, and now I have highlighted 40 bytes. So 16 plus 16 plus 1, 2, 3, 4, 5, 6, 7, 8, 40 bytes. We can see that now 41 and 42 are P and K. So that explains the 28,231. That starts here. So from this point on, this is just a zip file. This is normal zip file, but these 40 bytes are prefixing, are padding the file to begin with. So let's look at what's in that, because I find this interesting. So the first 4 bytes we can see here says navx. And if you have been on the extension wagon train ride since this whole thing started, you know that the first versions of all the extension stuff with nav was, the file name was called navx. And this is the prefix. So we can see here that there's a prefix saying navx. So the first 4 bytes are identifying what it is. Then we have an integer here, and this integer, if we look at the int 30, so this is the line you're going to look at. If you look at the int 30, you will see that this says 280000, but that's hexadecimal, and that this is how you store the number 40 as an integer. So 4 bytes. So this one tells you how big is the header before the zip file starts. This is important. We'll get back to that in a bit. So now we know what the first too many figures, what the first 8 bytes are. So let's continue. So the next 4 we can see again that has the number 2. What is the number 2? Well, remember at some point this was called extension version 2. So what happens if we find a old extension? Let me keep this open. An old extension 1 file and take a look at this. So we have the first 4 is navx, so the same. The next 2 is 40, and now we can see that. Let's see if we can get this to change into the, there we go. So now this is the number 1, because this was extension version 1. So they got room in the file format for 4 billion different versions of extensions. So I think we're covered on that. So those were the first, there we go, the first 12 bytes of the 40. So we have the identifier navx, we have the size of the header, we have the version, extension version. Then the next, where we are with the next 16 bytes is actually a GUID. And if we go back to tic-tac-toe, say, okay, that has to be the app GUID, right? That's our GUID for this app. Oh, where are we? But it's not. So this is what is known as the package ID. And the package ID gets generated every time you compile. This is why it's very important to actually keep if you ever deploy an app file to the cloud, it's not enough to be able to recreate the file from source code and pipelines and build servers and all that good stuff. You have to keep the exact same file if you will need to upload it to multiple tenants. Otherwise, the cloud will say this is not the same one. You cannot upload 2 different apps with the same version number. So that is because every time you compile, a new package ID is added to the header of the app file. And those are those 16 bytes. So now we have, who's keeping track here? I think we have covered 28 bytes or something like that. So the next thing is that we can see here that now we get the number. So again, 4 bytes to an integer. So now we get the number 28,231. But if you look closely over on that side all the way, you can see that the 64-bit, so 8 bytes make up a 64-bit, a big integer. So we can actually see that now we have 1, 2, 3, 4, 5, 6, 7, 8. And this is the 28,231. That's the size of the app. So they're prepared to have 4 billion versions of extensions, frameworks, but they're also prepared to have extensions that are more than 4 gigabytes in size, which is interesting. Maybe we need to test that out at some point, see if we can create the world's biggest extension and see how we can break nav with that. So anyway, so the size of the zip file is 64 bits, 8 bytes, and now we have the last 4 are the navx identifier again, and now the zip file starts. So that's a normal app file, but the normal app file has a cousin, has a friend. The normal app file has a friend called the runtime app. So let's take a look at that with the hex editor also. Here we go. And we can see that starts with the same thing as we see if we can get it to get the, yeah, there we go. So let's start with navx. It goes with the 40 bytes again here. Version 2, we have a let's actually just see the file size of this guy. It's where is it? It's 3,338 should probably be the zip size. Did I count that wrong? Well, I didn't, but we'll get to that in a second. So we can see that this one says 3,330, and we clearly said that the file was 3,378. So we have the 40 bytes, and the header says 40. But if we look at this now, we can see that where we would expect the PK to arrive at byte 41 and 42, it says .NEA, and so something is very different in this runtime app. And so let's go back and see here. So we have a size, and the size is 3,330. And we get down to navx, so the 40 bytes are the same, but then it says .NEA, and I have never confirmed this, but my guess is that NEA is for nav encrypted archive. Just my guess. And we have something that I can only describe as a 0. And then you see now the random stuff starts. So the random encryption in this case starts after the 48. meaning that then the math checked out. So 3,330 plus 8 plus the 40 is the 3,378 bytes. So the runtime app is a different kind of file type. It's encrypted, so we cannot open it with anything that we know of. Maybe that's a video in the future. I'm not 100% sure that's proper. Anyway, we'll figure that out at some point. So the header is the same. So the system that reads an app file will read this and then figure out, this is runtime app. I have to manage this different than a normal app. And all that is controlled by the header again, as you can see. And I think we're at 25 minutes, so that's probably a good time to call a quit on this thing. I hope this helped you guys in knowing what an app file is, and it's always a pleasure when I have the privilege of goofing around in a hex editor to show you guys what's behind the scene. So until next time, remember to subscribe, and if you enjoy videos like this, let me know in the comments below, or if there's anything else you want me to debunk or dissect as the Mad Doctor, I would be glad to do. So until next time, have a wonderful day.